So, hello students, hope you're doing well. So far we have done or we have finished chapter 1, which is the motion. Now we want to start with chapter 2, which is the velocity. So it's also an easy chapter if you study very well. So you will not face any problem. You must study the rules, study the definitions, and everything will be okay. So let's start. Velocity of a moving object. So what are the objectives of this chapter? So first, we want to distinguish between time and duration. Know what's the average velocity or the average speed. Know the units of time, the distance, the velocity, according to the SI system. So let's start. What do we mean by instant and duration? So instant is the time at which an event takes place, such as the beginning and the end of an event. So let's say the physics period starts at 9 a.m. and ends at 10 a.m. So what do we mean by instant? So 9 a.m. is the instant because it's the time where the event started. So the physics period starts at 9 a.m. So 9 a.m. is the instant, the beginning instant of the event. And 10 a.m. is the end of the event. So it's the instant at which the event ends. So this is another instant. So this is the first instant, and this is the second instant. So T1 and T2 are called instants. So T1, which is 9 a.m., is called the instant, and T2, which is 10 a.m., is called also the instant. So now the time interval between these two instants, which is T1 and T2, is called the duration. So if we subtract 10 from 9, we obtain 1 hour. So the duration 1 hour, which is the time between these two instants, is the duration. So the duration is the time separating these two instants. So the duration delta T is the time between two instants. We can simply subtract the final instant from the initial instant, we obtain the duration, which is delta T. So now, how can we measure the duration? So the instant is simply measured by the clock. So you look at the clock. For example, now it's 4:54. So this is the instant. I'm looking now at my watch. So I use the watch to see the instant. However, if we want to measure the duration, we use something called the chronometer. So the chronometer is like a timer in your phone. So you select the timer at your phone and let the time flow. So this is the timer. So if we click on the chronometer, it's time 0, let's say. It's 0. The chronometer indicates 0 now. Then I press this chronometer. After some minutes, I then stop it. So the first instant was 0. The second instant at which I paused the chronometer, it's 1 minute 23 seconds. So the duration is T2 minus T1, which is 1 minute 23 seconds minus 0. We obtain 1 minute 23 seconds. So the chronometer is the instrument used to measure the duration. Now, what's the SI unit of time? So the SI unit of time is seconds, S. So we have some conversions we must study, and it's very easy. In fact, so we have hours, minutes, and seconds. From hours to minutes, I multiply by 60. From minutes to seconds, I multiply by 60. From seconds to minutes, I divide by 60. From minutes to seconds, I divide by 60. If I want to go directly from hours to seconds, I multiply by 3,600. And if I want to go from seconds to hours, I divide by 3,600. You must know that 1 day is 24 hours, 1 month is 30 days, and 1 year is 365 days. So this is a direct application about the units of time. So if we have 3 hours, 20 minutes, I want to convert into seconds. So from hours to seconds, it's times 3,600. So I say 3 times 3,600 plus 20 minutes. I want to convert it into seconds. So I write 20 times 60 to obtain seconds. So we obtain 12,000 seconds. Also, if we have one day, I want to convert it into hours. So one day is 24 hours, so 24 hours. And from hours to seconds, I multiply by 3,600, then plus 12 minutes times 60 to obtain seconds, plus 35 seconds, already it's in seconds, so I leave it like it is. Okay, so I obtain this amount of seconds. If we have 1 hour, 3 minutes, 5 seconds, I multiply 1 hour by 3,600 to obtain seconds, plus 3 minutes times 60 to obtain it in seconds, plus 5, it's already in seconds. Okay, so now what do we mean by average speed? So in fact, we have two types of speeds, the average and the instantaneous speeds. So what do we mean by the average speed? And what do we mean by the instantaneous speed? So the instantaneous speed is the speed which is of a moving object at a certain instant. So remember the instant here? Remember the instant? So at this instant, I look how much is the instantaneous speed. And this speed is measured by something we call the speedometer. So you know in the car, the speedometer, which shows us the speed of the car at certain instance. So if I look now at the speedometer, I realize that, let's say, it's 72 kilometers per hour. So this is the speed at a certain instant. So this is the instantaneous speed. However, what do we mean by average speed or average velocity? So the average velocity is the speed of a moving object during a certain duration, at a certain duration. So I cannot take the time instant alone, no. I take the duration. So let's say, hold and draw, okay. So first of all, if we have a distance, 10 meters, and we have the duration 5 seconds. So the duration is given 5 seconds, the distance is given 10 meters. So to obtain the average speed, we say V average equals to distance over delta time. So what's the distance? It's 10 meters. What's the time? The delta time, which is the duration, is 5 seconds. So we obtain 2 meters per second. So if the distance is expressed in meters and delta t in seconds, then the V average will be in meters per second. If d is expressed in kilometers and delta time is, or the duration, in hours, then V average will be in kilometers per hour. So what's the average velocity or the average speed? It's the ratio of the covered distance to the duration of its motion, not the instant, the duration. Now, here are some important units of distance and their conversions. And we have the units also of velocity. Already we have seen the units of time, hours, minutes, seconds. Now we want to see the units of distance and the units of velocity. So kilometers to meters, we multiply by 1,000. From meters to kilometers, we divide by 1,000. And the SI unit of distance is meters. We have the units of velocity from kilometers per hour to meters per second, we divide by 3.6. And from meters per second to kilometers per hour, I multiply by 3.6. And the SI unit of velocity is meters per second. Okay, this is again the distance, the rule of the average speed. So we have this pyramid. You can easily study the rules, or you can easily extract rules from this pyramid. So we have here D, we have V average, and we have delta T. If I want to determine the rule of V average, it's distance over delta T. If I want to determine the rule of delta T, which is the duration, it's D over V average. And if I want to determine the rule of the distance, it's V average times delta T. So as we said before, the distance is in meters. The SI unit of distance is in meters. The SI unit of V average is in meters per second, and the SI unit of duration is in seconds. Okay, so as we said, the instant T is the time at which the event takes place, such as the beginning and the end of an event. The duration delta T is the time between these two instants, so it's minus. So T2 minus T1. And we use a chronometer to measure the duration. We have seen the units of time, and the SI unit of time is seconds, and we have learned to convert from one unit of time into another. We said also that the average velocity is the ratio of the distance to the duration of its motion. So the average is d over delta t. Okay, now a side note, if we have the distance in kilometers and the delta time in hours, so that the average will be in kilometers per hour. And we can convert from kilometers per hour to meters per second so we can multiply from kilometers per hour to meters per second, we can divide with 3.6. Okay, so as I told you before, the speedometer is the instantaneous speed of the car. So this circle that you see in the car, it indicates the instantaneous speed of the car. And it's at a given instant. So let's say now I looked at the speedometer, I found it 0. So it's 0 kilometers per hour. So this is the speed at this instant. Okay, now what about the types of motion? So we have 3 types of motion according to the speed. I have accelerated motion, I have uniform motion, and I have decelerated motion. What's the shape of each of them? So the accelerated motion is an increasing straight line. So you can know from the increasing straight line that we have an accelerated motion. And the speed, which is v, meters per second, the instantaneous speed will be increasing with time. So with time, the speed will be increasing. So each time, the speed is increasing. Each time, the speed is increasing. So we reach till the last point, and we see that it's the maximum. So the instantaneous speed is increasing with time. And with increasing straight line, we can note that this is the accelerated motion. Okay, if we have now the decelerated motion, so it's a decreasing straight line, and the instantaneous speed will be decreasing with time. What about the uniform motion? So if we have constant speed, so each time the speed is the same, and it's parallel to the time axis, so we can say that the instantaneous speed is constant with time. So this is all for this chapter. Hope everything is clear. Please, if you have any questions, let me know. Okay, so let me ask you a question. Can you notice this straight line? Can you specify the nature of motion? Yes, of course. We have the speed in kilometers per hour as function of time, which is in seconds. So because the line is decreasing, or the straight line is decreasing, so we can say that we have a decreasing straight line and the velocity or the speed is decreasing with time. So we can say that this is a decelerated motion. What about this line? So this is a uniform motion, of course, because the speed is constant with time. So it's not changing. It's all the time 100. So if I asked you, let's say, to determine the average speed here, so how can you do it? So first, we take time 1 is 0, okay? And time 2 is 8, okay? So I want to determine now the duration. The duration is T2 minus T1 is 8 seconds. Okay, so I want to determine the distance. So I have the speed, I have the time, I want to determine the distance. So simply the distance equals to what? Equals to V average times delta T. So what's the V average here? In this phase, it's, let's see. In this phase, it's, okay, so let's determine the VR, let's determine the distance in this phase. Let's determine the distance in this phase. Okay, so the distance equals to V average times delta time. So the V average is D equal V average times delta time. So delta time here, I notice what's the second What's the second time? It's 25 seconds. What's the first time? It's 8. I subtract 25 minus 8, we obtain 17 seconds. Also, I have the V average all the time is approximately 100. So I multiply 17 seconds times 100, I obtain the distance separating it. So this is all for this chapter. We have distinguished between time and duration. We have known the units of time, the distance, and the velocity according to the SI system. We have distinguished between the average velocity and or the speed and the instantaneous speed. And we have determined graphically the nature of motion. So hope everything is clear. Please, if you have any questions, let me know. Thank you. Bye-bye.